And we're gonna transition to the talk that's gonna share more insight about what kind of pipelines can be used for machine learning, and in particular, Azure or Azure Arc. And Mahesh is gonna present their work on this.
Hi, welcome to this session. Here we will talk about MLOps on Azure. We will discuss how we are using continuous integration and development on Azure to provide the benefits of machine learning as DevOps does to software. What MLOps does is it allows you to pipeline your machine learning process through code. And that's what we're going to discuss today. So I'm Mahesh. I am a product manager in the Intelligent Edge Solution Group at Microsoft, and I'm mostly responsible for running machine learning services like MLOps and more on Azure Stack or Azure Edge. So without further delay, let's get started. So before we get started, right, I love to set this context, which is that why is cloud so important, right? What is cloud providing the world? So last 10 years, we have seen tremendous growth in cloud. And what sense of cloud is that it allows companies to put all their data together. Once they have their data together, they can use machine learning to find patterns in that data. Once they have the patterns, they can use AI to make it actionable. And then they are using IoT to generate that crystal clear data in form of data models to provide this virtuous cycle, or we call it the data enabled organizations. So this intensity that we talk about comes through this, right? All your data patterns actionable, and then a way to exponentially grow that data inside your organization. That's what cloud is, and that's what cloud provides you in essence. In today's session, you will see how we achieve this at multiple levels. So this is a very high level. This is essence of what cloud does and why cloud is so important. Now, if you look at today's session, we will have MLOps as an overview. We will talk about who are the players involved in that, what is the life cycle, where are companies at level of maturity, and we will also discuss some of the demos. So without further delay, let's get started. So if you look at this, right, that's what MLOps is. So you saw that virtuous cycle. Now let's go a bit deeper into that. What happens is you first thing you do is you train a model. So you take your data, you put it in some algorithms, and now it can do some predictions. That's a machine learning model. Then you package a model, hopefully in a container or as a web service endpoint. You validate it. Is it doing the job? Is it fast enough? Is it what it is supposed to do? Is it meeting the KPIs of your organization? And once it does that, you deploy it, which is you make it available for people to send requests and get results, or within your app, you can see your faces and all. That's what you have deployed. And then you continuously monitor that model. You monitor it to see, is it meeting your KPIs of speed? Is it finding any anomalies in the data? Is it drifting, which is that data you train it on and the data which we are getting to this model is different? So all this happens during the monitoring phase. And at that point, if it is drifting or if there is more data, you go and you retrain. So this is that virtuous cycle that allows you to use machine learning to find insights in your data and do predictions. Just one aspect of the Uber idea we discussed earlier. But how this is achieved. So that's what we will discuss going forward. So if you look at, just before we go and deep dive into how we achieve this, let's see what has changed in the DevOps process. So DevOps process for code was pretty simple. You write code, you do unit test, you put your code as well as your friend code, you do integration tested, you're running, you deploy your system. But what has changed with machine learning is this data and this probabilistic idea that now there are no yes or no, there is no logics. The idea is that we will give you a prediction which is 87% accurate and it is as good as the data you fed. With data, we have to run some additional tests. Like, is the data clean? Is their data skewed to a particular class? Like, is it doing great for men but not doing great for women? Do we have equal representation of people? all that are added to the data test. Then you build a model. You have to test a machine learning model, and that added another layer of complexities. And that gave us this idea that DevOps, which we had for code, is not gonna cut it for machine learning. And that's where MLOps, GitHub 2.0, data science 2.0, all these lingos came to life. But that's basically essence that we have to provide 3 more or 4 more things, which is data tests, in prediction monitoring, system monitoring, and retraining. That didn't existed earlier. And this has to be a continuous process. And that's what we are trying to do and solve with MLOps, or continuous integration and development with data with Azure. If you look at this, right, in this journey, there are many players in this journey. One is your data engineer. This is the person who is responsible for putting all your data together. So I talked about cloud allows you to gather that data. This is that role. The data engineer, his job is to put all the data in Azure Data Lake, where you can put structured or unstructured data. Use Data Factory, which is an orchestration to clean that data, put it in some kind of catalog, and then you use tools like Azure Databricks and Azure Machine Learning to build machine learning models out of that, or process the data on Spark or Hadoop clusters. So that's pretty much a data engineer does for us. Then comes the data scientist, whose job is that I discussed, that he takes that and he builds a machine learning model. He uses open source frameworks for deep learning like TensorFlow and PyTorch, or traditional stuff like scikit-learn to build machine learning models. To build those models, they use compute on our cloud, which is CPU, GPU, FPGA. And GPU's FPGA does an awesome job for training, because this is a very compute intensive job, and matrix multiplication happens great on GPUs because it has so many cores in it. That's why data scientist has to have this different kind of compute and a cloud scale of that compute. And then your ML engineer takes those models, deploys them either on a cluster, on a Kubernetes cluster, or on an IoT device using our IoT Edge portfolio, and then continue to monitor them using Azure Monitor for skews, for corrections, for prediction results, as well as for drift detection. We will talk a little bit more about drift, but these are not only the 3 roles, there are more. There is IT involved, there is data analyst, business owners, and many own who define the whole scope of machine learning within your organization. So once you have all these, where are companies? So these are the 3 roles or 4 roles or 5 roles we discussed, right? But where are MLOps is the process which is allowing companies to take templates and adopt or iterate faster in machine learning. And you will see that where are the companies in this journey, right? We interviewed a lot of companies, and my job allows me to work with a lot of companies. And we have seen the companies in this 4 levels. And we have divided their journey into training a model, releasing that model to production, and then monitoring it or integrating it into the apps. So if you take these 3 pillars, there are 4 basic stages where companies are. We'll discuss and deep dive them into detail. The first one is, okay, you have a very clear data pipeline. Your data engineer has a way to accumulate your company data. Your data scientist comes in, use the data catalog, prepare some data, use their best algorithm, find a useful model. It solves that business objective, and then they don't know what next. They take that model, they give it to IT, and some guy is putting it in production. And if there is a query comes in which says, hey, how you build that model, or can you reproduce it? They're very less likely to reproduce it. That's the first organizations. Many of our organizations start like this. They start finding insights, but they don't have an end-to-end process defined. The second path in this journey is they have created not only a data pipeline, but a machine learning pipeline. So the data scientist here basically registers their data sets, have a clear environment, check-ins their code, logs and outputs, and then the others can see what he did. So if one data scientist leaves, the other can come in and see what they have done and pick it from where they left rather than restarting again. And they put it in model registry, right? So they also register their models. Uh, on Azure, like, let me just quickly show you a demo of this, that how would you do that on Azure. So basically what we have done is we have provided Azure Machine Learning, which is our single pane of reference for doing machine learning on Azure. Here, a data scientist brings his notebook, and then what they do is they create a compute. We allow you to create a compute, a cluster. You can just create with a click of a button on our cloud. And once you have a compute, we also give you some data stores. This is where you will store your files to uh, take your data and consume it. And you can connect a number of kind of data like SQL Server and all as data stores. Once you have your compute and data defined, you basically go and you can register a data set. So now this is a registered data set. Next time people want to know how you trained your data, this was the data set, and you can register as many as you want. As you clean your data, you can continue to have a history of that data. Then you can look at experiments. And once you have trained your model, you can also register your model. So now this is a registered model. And this is how a machine learning, a data scientist can create reproducible machine learning pipelines using these tools, registering each and every step of the process. And if you look at like the experiment, you can see what we have tried in that experiment, right? So you see that we have completed one experiment, and this was my alpha for that. And this was my accuracy. My mean square error rate was this. So all this can be reproduced, and this is like the first stage of companies. So you can get started and do this. Second stage, what we see is that now the ML engineer in these companies takes that model, package it, certify the model that it is good or not based on data set and is the explanation there or not, and also release the model and watches the events, notifications, do a continuous integration and development of that whenever this new model comes in, it get deployed to some production scale data uh, clusters, and you can deploy them on cloud or your edge devices. This is also a easy thing on our Azure. Same way, like once you have your model registered, what you can do is you can just click the model and say, okay, I want to deploy this model. And in a click of a button, you can deploy it using Azure Kubernetes service or just a single container instance. Or you can provide your own compute type, which is whatever you have attached it as a compute. Enable authentication or not, your choice. And this gives you an endpoint once you have deployed. So that endpoint where you will send your queries for. So this is how the third stage of companies work. So now you have a recreated pipeline for training as well as deployment, and both of them are working for your organization. But this is not the dream why you came here for, right? You came here to do end-to-end each and every pipeline. That's the level 4. This is an end-to-end machine MLOps for machine learning. And how this works is that all your data remains here in data store. Your data scientist can train this model using any of these frameworks on using Azure Machine Learning or Azure Databricks. The data scientist checks that training code. That triggers a QA pipe. That triggers a pipeline, and out of the put of that pipeline is publishing this model. That goes to your dev model registry, which triggers another QA pipeline process. And that tests all your models. Is the model good enough? Run some basic tests. And if that is good enough, then they copy it to a QA model registry. And that model registry deploys it to some cluster where a QA engineer will go test the models, or these can be automated in real time. Once that is approved, the ML ops engineer takes that, deploys that through their pipeline to a real cluster in production, or creates a batch cluster compute where we can send inference requests. And all this data, once this is real-time detected a problem. This can even trigger a retraining pipeline through Azure DevOps. Both dev, QA, and production environments are separate, so they don't see each other data or each other code, each protected by their own key vault on cloud. So now all these roles come together, and with a single Azure DevOps plane, we manage the machine learning as well as your traditional code. And all these tools are provided to you. Now this looks a little bit complex. So let's do a live demo of this and see how this comes to life. So what we have done is, this is our open source repo, which you can take and try. This is what I did. I will show you. So this is how you can get started. So I will share this link with you. Basically what you do is you come here and you see the same diagram that I discussed. And all you have to have is an Azure subscription. And that's it. Rest, all the code, all the pipelines are provided to you. And the first step of that process is just getting started, right? So you click on this getting started document, and what you land up on your first step, which is basically you provide some of your credentials of your Azure, like your workplace name, your resource group, which you want to create. And once you fill this information, you run your first script, which is nothing but you create your pipeline and you provide us the service principal for your subscription. And once you have done that, you get your infrastructure as a code pipeline. So that's our first pipeline. What this pipeline does is, let me just take you to my pipelines, and I have ran this beforehand, so I can just demo it and show it to you. So if you look at the first pipeline, what it does is it creates all these resources for you. So let's look at that. So what it does is it checks this out and deploy resources to Azure. So what it does is it creates all the required resources. So you need not to worry about creating what storage you will need, what machine learning operations you need, what compute you need. You just come here, you take our node, this YAML file, and it creates all the resources required to run your machine learning job. Once you have done that, the second one, what it does is, so this is our infrastructure as a code create environment, and it creates a resource groups. And then you can check in your resource group, you will get all these keywords, your machine learning workspace, which I talked about earlier, your application insights, all is created for you automatically. The second thing you do is you allow the subscription of your Azure machine learning also through service principal, so that this code can access and create. So DevOps can create resources or run jobs for your machine learning workspace. So just come here and add a service principal. And after that, you run your second one, which is first you're going to go and create your end-to-end pipeline for training and registering. And then you're going to release it. And then even you can do it for batch scoring. And all these are ready to go pipelines. So the first pipeline which you run is your model CI. The second one is train and evaluate. So that's exactly what I did. If I go to my pipelines, you will see that this is my model train and register pipeline. And what it does is it creates the model for continuous integration. So now you are looking at this. It checks out my code, runs some tests, some lint tests, some unit tests, and make sure my code is good. And then what it does is it creates and publishes this as an Azure machine learning pipeline. Once this job is done, what you can see is that you can go to your workspace and it registers this pipeline for you. So now you will have a pipeline on your Azure machine learning workspace. Then you come back. And what you see is that the next step of this is that you run this job of train and evaluate your model. And this just checks out, gets a pipeline ID and runs that. So this one, what it does is it invokes that ML pipeline. Each pipeline is an endpoint, so it can be called as a REST endpoint. And what you do is you go and take that and register this model. You will see that that's the model it generated through the pipeline. Let me show you that here. So this was my pipeline. What it did was we triggered it from the DevOps. And what it did is it trained the model. And when it trained the model, you can see that that was the script that it trained. This was my matrix when I ran this. And you will see what images were used, what are the parameters used during this compute. Then it ran some job for evaluation, which was the script. And you can even see what the code was and what the snapshot of that code is if you need to go and debug this. And once the model was evaluated, the model was found good. And you saw in our logs, that's where we have registered the model. So now all these processes automated and run through this pipeline. So this pipeline basically does this. And once it has done that, it also publishes some artifacts for the new model. That triggers another pipeline for us, which is the deployment pipeline. So now we're not only storing the model, we are also storing a JSON file which talks about what the model is, what the content of that model are, how to run that model. Those artifacts are also stored. So once you have done training and deployment pipeline, the third pipeline in this journey, which is here and you will have it. Then what you have a model now, you have the model artifacts. The next process is deploying this, the ML or the DevOps or ML engineer job. For that, you have another pipeline. All you do is you just set up that pipeline and run it, which is just a YAML file. And you just bring this YAML file to your pipeline and hit run. And what that does is it just takes your model, deploys to an Azure container instance. Once that passes, it deploys to an AKS cluster, runs it on scale, or even take it to a web app. So these are all the things you can do today. In the end, what you get is this end-to-end pipeline. What it does is it first takes and create your pipeline, use that pipeline code to train a model, register a model, and then deploys to a Azure container instance or AKS without you writing a single line of code. All this is given to you in each, like one by one steps. There is a Pluralsight tutorial. This link is there. If you just follow the instructions, it should be up and running for you in 2 hours. If not, we are here to help. So you have seen all this pipelines, this was my deploy pipeline, and that's what I've done. I deployed it to my Azure container instance, and that pipeline just created that, took those artifacts that the previous pipeline created, took it, created an Azure CLI, and deployed it to an ACI. And now this model is ran. It also did some smoke tests by sending some data to it and got some results. So this was the URL that it was testing the service for. And these are the results it got. Those results were good. Hence, it went ahead and finished the smoke tests. So this is how this whole end-to-end journey, which we were discussing on our slides, come together, which is that now if you check in a new code, whole of this will get executed and your new model will get deployed. So this is how we are doing DevOps and CI/CD on Azure. What this allows you to do, it allows you to track everything, your code, your data, your configuration, so you can reproduce it. It allows you to create package and deploy in a click of a button. It allows you to do end-to-end integration into your DevOps workflow. It does only not work with DevOps, but the same experience which you saw with DevOps is also available with GitHub Actions. So if you love GitHub Actions, then we also have a sample for that. We also generate events. So you can see when a new model is registered, deployed, or a run is completed or drift detected, you can chain different jobs. And we have a sample where you show you that whenever a drift is detected, you can send an emails, or you can monitor that drift and you can trigger another training job from your data factory. So if you see your model is not behaving and it needs to be retrained, this whole process can be automated by using those events of data drift and creating or running a pipeline in Azure Data Factory to retrain and find this new data and redeploy, all automated without a touch. So these are all the examples or CI/CD things I wanted to talk to you. Few examples of customers. This is our teams. The teams team put all the videos together in data sets, process them, and then create these training sets which are for our campus, and they create them differently with different authentication so different teams can get only data that is relevant to them. The ML engineer uses that, creates these models, evaluate those models, and put them in practice. And these are the models which find out the best quality for a video, like this one. And then we deploy, we do some A/B testing, evaluate, and then the best model get deployed. Similarly, you will see all these three roles coming together. Similarly, there's a transport company that uses 16,000 models for deployment, and they wanted to predict the departure time of the buses. And they have to retrain because that condition keep changing on their cameras. And how they are doing that is they use DevOps to build and retrain their models. Anytime they have to retrain, there is a new model that goes in. They provision new data, they train the data, they deploy, run some tests, they use a manual process for approval. Once the model is deployed, it get and start predicting. So this continuous integration or continuous detection of drift and retraining pipeline is what allows them to predict these times correctly at different time of the day, different environments, and continue to adapt to ever-changing world. With that, this is all I wanted to talk about today. That's the link. The first link will allow you to get all ML Azure things. Our machine learning pipelines are at MLOps.python. The last repo is also very cool and important. With this repo, what you get is not only what I showed you, just a template, but what you could do go and do is you can have different examples. So here we have put examples of how can you build a recommender system, an end-to-end pipeline for video anomaly detection with Databricks. So not only Azure Machine Learning, you can run MLOps with Databricks and Azure Machine Learning. You can also see a lot of different AI architectures. You can build in natural language processing. So this is a really good one for you. Go and do practice. So a few action items. Please look at these repos. Please give it a try. And I'm so excited to see what you go and build on top of MLOps. Thank you. Again, my name is Mahesh, and I'm so happy to be here. Thank you.
Awesome. Thank you so much, Mahesh, for such an exciting presentation. It actually looks really, really nice. I can only imagine how happy your customers must be. The UI and the features are just amazing. Since we're a bit behind time, I'm gonna just ask one question because fortunately we're gonna have you as part of the panel, so I hope we can continue the discussion. But the question I had is, so you mentioned that, for example, DevOps is not sufficient for MLOps, essentially, just because it doesn't cover some of the use cases. And I would actually argue that it's only the limited DevOps because if you think about the regular CI/CD, what you actually want to have, you want to have a closed loop where you deliver your, let's say, application, and then you start monitoring it. And then let's say you build a profile guided optimization profile for it. Then you pipe it back into the pipeline such that the next deployment is going to take into account the performance characteristics. Or maybe if you use JIT compiled language, you can build the profile and then feed it back into the next release. So you essentially have these closed loops similar to what you have in machine learning, essentially. It's like relearning the model. It's just the model in this case is not necessarily like machine learning model, but it could be a profile guided optimization. So my question is, how much are you able to reuse across your different offerings? Because you obviously have offerings for DevOps, where you have an amazing products for CI/CD space, and now you also have the MLOps. So I wonder how much infrastructure, internal infrastructure, you are able to reuse between these.
Yeah, no, thank you. That's a good context, right? How I said it made you feel like it is not what we are using. But you're absolutely right, right? That the cycle and the build and the trigger on build and going to the next process is very core of what DevOps provides. And that continues to be the case. What machine learning and what we are adding through machine learning or through Azure machine learning into that is what happens when you register a data set. How you automatically detect your entry of data is different than what you registered in your data set. So these triggers, which will again the whole DevOps pipeline will use and continue to be reused, but these events and these triggers are the add-ons, like the model drift detection, the registration of data sets, the event when a new model is registered, the event when a new model training finished. All these are providing the hooks for you to adapt the current DevOps to this new machine learning paradigm. And just to answer your specific question, like how much we were able to reuse, you see, we are using like almost 85% of what DevOps is. And if you look at like what we have done with DevOps with other like MLflow and Databricks, it's not like the same process and same what you discussed just happens, but it happens for machine learning triggers. And that allows us to serve this new audience with the existing tool chain and not relearning or just ramping the whole world on something new. So that's where we stand.
Fascinating. This is awesome stuff. And I cannot help but I'm going to ask one more question. So, but are you also able to maybe bring back some of the lessons from MLOps into the DevOps? Like maybe do you have some plans to extend your DevOps offering with some of the new components that you have built for ML?
Yeah, so I think we are already providing machine learning hooks for it. The events, like I showed you on my slide, now we have DevOps triggering on model registration, model training trigger, data set changes trigger. So these are the triggers that are landing to DevOps, and GitHub integration through GitHub Actions, which is already part of DevOps. Nothing's new from MLOps, but that's what we added this time. Next time you will see the data set integration as well as training events that you can trigger the DevOps for. So that's what the next charter is. So we bring the model
Awesome.
integration, training will come next.
Sounds awesome. Yeah, I'm looking forward to seeing what you're gonna release next. It's a super exciting time and super exciting product. So yeah, thank you so much. I hope to see you at the panel and continue the conversation later on.
Thank you.
So yeah, see you later.
Thank you, Darius. Such a pleasure. Thank you, everyone.